Hello, and welcome back to the Future in Review podcast. Here today with Mark Anderson, who is the CEO of Future in Review and the CEO of Strategic News Service and Pattern Computer. He is a busy guy. Got a lot on his plate. And one of those things was writing in this last issue of the Strategic News Service Global Report about the future of AI. And specifically in that issue, covering the future of three kind of major components of what he considers to be the future of AI. Mark, I'm wondering if you could start us off by just outlining those three components for us.
Sure. So, in my humble opinion, because everybody's got their own view of this world coming up, I think pattern discovery, I'm obviously biased on this. I think that
Right.
pattern discovery is the most important skill in computing, and therefore the must-have next step in what we're doing. After that, explainable or explainable AI or XAI, so that you'd understand how to learn from what you're doing. And finally, ethical. And I'd like to, at some point in this conversation, do a slight redefinition of what ethical means to me in a more mathematical sense.
So let's start with the pattern discovery angle of that. You had a very specific way of framing pattern discovery and its difference from what we're doing today.
Yes.
Can you explain that further? What does that mean? How is that different than
Sure.
what LLMs are doing?
Yeah, you bet. And I think it is confusing because, at least at Pattern Computer, we are very specific about that meaning. And I think in general, we probably use that term more than anybody in the world, but others have used it before. And so it's possible to be confused. It's a bit like pattern recognition, but much more powerful. So everyone does pattern recognition in their work with neural networks, with LLMs, with their brain. We're all comfortable with the idea that pattern recognition matters. In compute, the idea of pattern discovery is a little more refined and focused. So what it means, at least at our stage of work, is that you're not allowed any hunches. Instead of doing hunch-based work, which you were all doing when you had a neural network of any kind, including GPT, now no hunches are allowed. What you're going to do is take good, clean data, curated data, run it with your engines, your discovery engines. We call them pattern discovery engines. And the result will be the creation of hypotheses, not starting with them. And the result is you're going to learn a lot more than you knew before. There will be patterns you didn't even dream of. And this is real science. This is interesting.
Yeah, and it's worth mentioning that Pattern Computer as a company was founded on stage at Future in Review.
Right.
With the express goal of doing exactly this, right? We started based on your leadership. We started from the position of how do we find patterns in giant data sets without having to guess about what we think the outcomes might be? How do we open up that scope of, we have a hypothesis that this thing might be true and we're going to test that single hypothesis we're going to look for all the patterns in this data set, including patterns that we had no idea existed or didn't have enough computational power previously to recognize.
That's right. And I think you go even further to say all hypotheses, human-generated hypotheses, are biased. So what a crummy way of doing work.
Well, except for yours and mine.
No, mine are. So it's a ridiculous way to do scientific work or business work if you had any choice. So an example of why pattern discovery is better and really is different and matters, if we look, I think probably the highest order bit that we, as a computer person would say, that we have achieved in work at Pattern is the creation of new drugs for the top 5 cancers. We do a lot of that work. It's hard to do. Very few companies in the world have ever done it.
Yeah.
And we own 7. We're about to file 14 patents more. So we figured out how to do this pretty much. And when we worked on breast cancer, triple negative breast cancer, which was our very first challenge pretty much of any kind, people were writing papers about 1, they had a hunch about 1, or about 3, they had a hunch about 3, and then they would write a paper about it. Well, the very first run we did, we saw over 50 new genetic expressions related to that disease, correlated with dying from triple negative breast. It's a completely different universe. We didn't think they were there. We didn't
Right.
get they were there. We found them. And that
Well,
would
and also,
allow us to make steps that couldn't have been made otherwise.
I think that there's a very interesting way that you put this in your global report, which is, some companies will brag about being able to identify millions of possibilities.
Yeah.
You don't want millions of possibilities.
What you do is,
Millions of
oh, maybe
possibilities is
20
not
million.
that helpful.
Well, you do it 20 million possibilities. Yeah.
You would like to know which is the one that will be helpful for you, right?
Yeah,
And
one
I
or
think
5 or 10 or
that's
yeah, right.
that's a very good example of that in particular. Okay, so let's switch gears and talk about the next angle, which is ethical AI.
Once you've done what we just described, what would you want to do or know next? If you were really serious about, well, what my friend Elon calls trying to discover nature, he hasn't done it yet. He's doing some other stuff instead. Not quite as valuable, I think. So, the answer would be, oh, well, I saw these genes, but I don't know what they're doing. I don't know how they work. Are they working together in teams or not? Maybe. What are they like? Do we know they have shared attributes that would tell us something about the disease? All the questions you could think of once you've seen the targets in a particular problem and the parameters they're called. So, what is their contribution? Can I figure it out mathematically? Can you tell me how they rank from top to bottom in the top 30? Can you tell me in an equation that I could cut and paste out of an Excel sheet? What's the actual equation of their contribution to the outcome? Death for this woman, yes or no? Tell me how that happened in a mathematical, clear, parameter-driven way so that I can learn and make a drug using that information. So that's called explainable AI. Now, again, the semantics have come before the ability. So there are many people who've been dreaming of and talking about and bragging about explainable AI with a weaker definition.
Right.
So as an example, you could use statistics of various types to do what's called hinting, where you're either trying to recreate an outcome without knowing why, or you're trying to hint around the edges. You can't look at the edges and you guess at what's in the middle.
Right.
Probably ought to be called the cupcake theory or something. But anyway, you
And
don't
so
know.
just to be clear here, this is for the most of the AI industry at the moment, hinting, which is looking around the edges, is really kind of the cutting edge. Like they still are not able
On hinting.
there's yeah. They're not able to tell you why something happened, but it's considered a success if they're able to replicate that, right? And we see that in LLMs a lot with people talking about, well, we were able to get the same answer from this LLM as the other LLM, and therefore we think, or not, and therefore we think that they're X% accurate, right? Which doesn't tell you why you got that answer.
True.
It does.
In fact, the biggest problem they have, Berit, is the opposite of what you just said. They'll run the same LLM, the same version, on the same equipment, ask the same question twice and get two different answers. Oh, well.
Yeah.
Yeah.
It reminds me of the email that one of our members sent to us this week, Mark Brensky, yeah, about a study out of ChatGPT that found it got better answers mathematically when it was asked to pretend like it was a part of the Star Trek universe.
Star Trek, of course.
Yeah. The mathematic answers became more accurate. They didn't know why.
Yeah.
But yeah.
Well, we could talk about LLMs if you'd like to, but that, in terms of the value of explainability, hinting doesn't bring you what you need. But if you could actually see the internals and how the system did what it did to have an accurate prediction, then you would learn something. You learn a lot. You could learn what our friend at Berkeley Labs calls the soft physics, for instance, of protein folding, not just which letter is most often next to which letter, which is what a large language model will teach you. So you really want to know, why did it bend that way?
Right.
What are the physical laws of these different amino acids or these different atoms in a molecule bending in different ways? What are the real rules there, not just what are the semantic rules? Yeah.
And this is something
AI does that. Go ahead.
Explainable AI is something that Pattern has developed.
Correct.
Which we've talked about in past podcasts.
Yeah. We have two flavors of it. under the family name TrueXAI. One is the flavor we've been using for about 6 years because we baked it into the math that we created to look for patterns. So it was never opaque to us. It was always a glass box, not a black box. So that's terrific. And the other one we made especially to look at neural networks, which might be groundbreaking. I don't know if anybody else has done that. And that actually works with certain fairly straightforward neural networks.
And what are you able to see that others cannot using those techniques?
Internal. In both cases, we can see exactly how the system did what it did. We could give you a cut and paste Excel, cut and paste sheet of the equation of what happened there. What were the parameters? What were each contribution from each parameter in order?
Mm-hmm.
What's the ranking of those things? Do they act in families? Yes or no? What are the families? Is there a correlation there that's beyond the correlation with the objective or the unfortunate outcome or the fortunate outcome? So this is as deep as you can go in learning, I think, and we've got that. So we depend upon it every day.
Let's talk about the final angle. I misspoke earlier and said the second angle was ethical AI, but actually the second angle is explainable and the third is ethical.
That's right.
Let's talk about ethical AI.
Sure. So to start with current use, now I'm going to play the part of a rabbi. Ethics in society, you begin with the idea of an inborn, maybe it's a religious or a social sense of culture or what's right. And if everyone agrees, then someday it becomes a law. Mm-hmm. So it's like the first step toward law. But that law sanctifies or memorializes those things which our society in our country or our town or our family believe in. That's a very tentative kind of situation because it can change from mile to mile away or country to country. So that idea of moral ethics, while very valuable culturally, is not very valuable mathematically. And I think as the world becomes one place in terms of using AI, we need something which is everyone can agree upon.
Okay. Good luck.
Working on it.
Mm-hmm.
So the redefinition I mentioned a few minutes ago about ethical would be this, that instead of saying something about race, creed, color, or gender, or whatever in the data, that remains a problem. And I think, we could talk about data curation,
right,
and the ethics of clean and properly curated data. That's all that people seem to be talking about basically now, almost, except for Google. Google had a different problem. So instead, I think what we would like to say is given that the data has been properly gathered and curated, what do we mean by ethical? And the idea there is if you do that, if you do the curation properly, when you run a discovery engine against that data set, an interesting thing opens up for you. That is the ability to make major unexpected discoveries, pattern discoveries. Now, if the data were not clean, if it were biased, or your system were built to be biased, like Google just had, all that stuff, if you have inborn bias, then you're not going to get there. But for the first time that I know of, this is the exciting part, I think we can take a quasi-moral idea like ethics, mm-hmm. apply a mathematical cleanness to it by knowing ahead of time what the rules are for gathering data and for curating it, and then equate ethics with discovery, with pattern discovery, because you can't do good work in pattern discovery if the other is not there. So by its nature, mathematically and functionally in computing, pattern discovery, to be effective, demands and commands that we have ethical AI on the front end. Not just because we want it there or because we have a certain religious or cultural belief. It has to be there for us to cure cancer.
So you mentioned in your report, looking back from 10 years from now at what an ethical data set might actually look like. And the fact that there might be certain standards of certification for this data set is ethical or ethically sourced or
Yes.
ethical in its whole in some way.
Yes.
What kinds of components do you see might be a part of that? Like,
well, one thing I said was we're not going to do that. We're somebody, much better at data prep, maybe, should make a business, I think, out of certifying that.
yeah,
That would be a real,
absolutely.
I mean, we all want to know what the gold standard is, and
Free business idea of the podcast.
free business idea. Somebody could make a lot of money by establishing a certification process that could be standardized around the world, call it the gold standard, whatever you want to call it. And then people who are hoping to do great runs can take that step and test and see, is it good enough? And we're trying to do that at Pattern with our own engines, but I would be the last person to claim we're the only guys who care,
Mm-hmm.
or the best. We might be early on. Everyone's concerned about this. So we need to have a fair, witness, little sci-fi plug there, where everyone would agree that witness, that company, that government, that agency, whatever it is, that standard, we all agree on that, and we're working toward it. Now you can start to think, once I've said that, well, what would you want to have in there? And there are some things which are just compute driven. So as an example, we have a tool which can go and just look at your own data set. We don't violate your privacy. We don't know what's in there. We're going to send this thing over to your place. It's going to look at what you've got. It won't bring any of your data back, but it's going to tell us about your data set.
Mm-hmm.
It will tell us, for instance, oh man, does she have problems with column 5? It's a
Interesting.
mess. I don't know who collected that.
Yeah.
So there is text where there ought to be numbers. There are blanks where there should be not blanks. The 0 is written out instead of a 0. All this kind of stuff happens all the time. So there's a very basic thing that you would do in terms of just having good data. It's not rocket science, but it's really important. Including, what do you put in there if you have to fill in the blank and it's just a blank?
Right.
Having a blank alone is not a good idea. So there are a lot of problems that can be solved pretty straightforwardly. You'd like to have people kind of all agree how to do that. And then you get into the part that we all care more deeply about in terms of what we call ethics, where who collected this? So what machine did they use? Well, they used different machines. Well, that sucks.
Yeah. What's
These
the
are
accuracy of this machine versus that machine?
I can't tell you what a problem that can be. So you think, well, I used a machine. It's a good scientific machine. We run into situations where genomic reads are done on different systems. Wow, they don't compare well at all. If you're trying to run stuff on that, and it's like, Bob used this and Nellie used that, good luck. I don't think you're going to have much success. So same thing with other measurement systems that are mRNA measurement or RNA, all these different things use very exotic, very exquisitely accurate machines, but they're not calibrated to each other. Oops. So
Oopsies.
yeah, it's a huge problem. You have to create for like slippage or linkage or something so that these are allowed to be wrong by a bit. So I think there are many things like that in data which aren't obvious. I mean, the obvious ones are the stuff everyone's read about, like if you train on men being executives, the system will tell you hire a man to be an executive.
Right.
That's so stupidly obvious that everyone knows it. But maybe there are a lot of more subtle things that we haven't figured out yet. And so understanding who collected, how was it collected, where was it collected, under what conditions, was the person tired on Monday and not tired on Tuesday? All these things that you haven't thought of. Were they tired at the end of the shift but not the beginning of the shift? All these things affect the outcome. And I think some people do it very well and they're very cognizant of it. They tend to be machine-like, right? That's what you're looking for. So if it's people, maybe you want to give them a rest after 2 hours and have somebody else come in for 2 hours. But whatever you're doing, do it consistently so that the data is consistent. Well, that's the answer, really.
Well, Mark, it sounds to me like we're going to have a conversation at Future in Review 2024 about the ethics of data collection.
That would be really smart. I think ethical AI, and how do we mathematize it and certify it, and then pave the road toward making terrific new major scientific and business discoveries that we couldn't have done until then.
Fantastic.
Yeah.
So if you're watching this podcast and you would like to become a member of the Strategic News Service Global Report, get these full reports directly to your inbox, you can sign up for your first year at half price in the link below this podcast. And then you'll hear from us every week, like it or not.
Like it or not. Thank you, Berit.
Thank you.
That was fun.